Hello, today we are going to talk about simplifying rational expressions. This is Chapter 11, Lesson 3, and you'll find it on page 690 in your book. So let's get started. So example 1. So this is going to be a note slide. So I suggest you take notes on this page right here. So as it rolls out, you can pause it, pause the video, and make sure you stay caught up. But we're finding the excluded values, and this may sound very, very familiar to you because we have already done problems like this. So again, it's the same concept as in Lesson 2, the exact same thing. We're setting the denominator equal to 0, and we're solving it. Okay. Now, what's different? What's different is the expression in the denominator will be a quadratic, which means you have to factor, and I know you guys don't like that, but that'll be okay. This will be a good review. All of these will factor, so there's not going to be any need for the quadratic equation or even completing the square. Everything that I throw at you will be fairly straightforward. Okay, so keep that in mind. And then mastering this, factoring the denominator, and in some cases we'll have to factor the numerator, for example 4, will help us complete example 4. So again, get these things down. We're still saying the denominator equals 0, but we're going to have to factor our denominator. All right, so I just want you to watch this example. Okay, you don't have to write anything down. Just kind of pay attention, watch what's going on, and then you're going to mimic that in a couple other problems. So the first thing we want to do to find the excluded values is we've got to figure out what makes this 0. But that's a little difficult because it's quadratic, so we are going to factor the expression in the denominator. All right, and I'm asking myself, what are the factors of 5 that subtract to give me positive 4? All right, factors of 5 that subtract to give me positive 4. Those values are 5 and negative 1. Okay, 5 times negative 1 is negative 5. And 5 minus 1 is positive 4. So we can do a quick little check there. And then just like we did with quadratics and just like we did in Lesson 2, we're going to set these binomials equal to 0. Okay? And that looks like this. X plus 5 equals 0 and x minus 1 equals 0. When we solve, subtract 5 from both sides, add 1 to both sides of this expression, and bam, we get x equals negative 5 and x equals 1. So these two numbers, negative 5 and 1, make this expression 0. And remember, we can't divide by 0, so these are excluded values. All right. Now, let's try this one together. So you're going to copy this problem down. 5x divided by x squared minus 81. All right, and so I'm kind of covering two different types of factoring here. This is still factoring a quadratic. However, it's a difference of squares, so it's a little quicker. All right. Now, this factors into x plus 9, x minus 9. You're essentially asking yourself factors of 81 that subtract to give me 0x because our linear term in our quadratic is missing. So we need this 81 to eliminate those x's, and that's what a difference of squares does. If I were to FOIL this back out, I'd have 9x and negative 9x for the linear portion for the O and the I in FOIL, and they eliminate. So all we really get is x times x is x squared, and 9 times negative 9 is negative 81. All right, set them both equal to 0. X plus 9 equals 0, x minus 9 equals 0, and we get x equals negative 9 and x equals positive 9. So again, if I put 9 or negative 9 into this x, it would make 0 for the denominator, and we cannot divide by 0. All right, so let's try this one on your own. So I'd like you to write this problem down, try to factor this, and find the excluded values. I'd pause it, and then when you're ready, check your answer, because I'm going to show the answer here. Again, this only works if you pause the video, try it yourself, and see if you arrived at the right answer. So here comes the answer. The first thing I did was factors of 8 that add to give me 6. That's 4 and 2. 4 times 2 is 8. 4 plus 2 is positive 6. I set them both equal to 0. And when I subtracted 4 and subtracted 2, I got negative 4 and negative 2 for my answer. So if you didn't get that right, check how you factored it. I guess the only other factor pair that would have made sense was 8 and 1, but 8 plus 1 is 9, and that's not our middle term. Okay? Now let's transition this into example 4. All right, and this is a note slide as well. So again, pause it, take some notes. You can shorten these up if you need to, and then we'll get moving on. So simplifying rational expressions. So what we're going to do here is the same as example 1. We have to factor the denominator. This could be factoring a quadratic or just factoring out a GCF, so undistributing. I know that's not a math term, but I think that's what you guys like to hear. That means factoring out a GCF. We might have to factor the numerator as well, and again, it could be a quadratic in the numerator. It could just be a GCF problem, but we may have to factor both the numerator and the denominator. And once both of them are factored, you're going to see that these expressions cancel out. Some of them do. And then we just write what's left in the numerator and the denominator, and that's our simplified expression. So let's take a look at one. And again, if you needed to pause this to write down the notes, go ahead and do that. Now, here's our problem. And what I see right away is that the numerator has a GCF of 4. So 4x plus 16, I can factor out a 4. Okay, or undistribute a 4, pull a 4 out of each of those terms. And then in the denominator, I can factor this quadratic. Okay, factors 36, that subtract to give me 5. So when I GCF'd the 4x plus 16, I took the 4 out, and what was left was x plus 4. And we can do a quick check. 4 times x is 4x. 4 times 4 is 16, and we are equivalent, so we're good. And then factors of 36 that subtract to give me 5. Now, one quick mention. Your numerator has a binomial in it. That should be a hint as to what your denominator is going to factor into. One of those factors is probably going to be x plus 4. Okay? So you might think 12 and 3, but that, again, doesn't really match. And 12 minus 3 is not 5. But 9 minus 4 is 5. And again, I need the, I think I copied this problem down wrong. Hold on. Let me take a look. All right, so I got it fixed. Again, we factored it, and this is where I messed up. That should have been minus. So we have factors of 36 that subtract to give me negative 5. That's negative 9 and positive 4. There we go. And notice that these two are the same factors, so they are going to cancel out. And we are going to write what's left, 4 divided by x minus 9. Okay? So again, we factored, we GCF'd, which is also a form of factoring, and then we wrote what was left after what was left canceled out. So let's take a look at this last one. I'd like you guys to try this on your own, so pause this video, all right? Give it a shot, and then unpause and see what you came up with. All right, so nothing to factor in the numerator, x plus 3. Also, this is a hint for what the x squared plus 10x plus 21 is going to factor into, okay? And so I'm thinking factors of 21 that add to give me 10 are 7 and 3. So that's going to give me x plus 3 and x plus 7. Again, these cancel out, but there may be an issue for some of you here because nothing's left in the numerator. So what is our placeholder when everything cancels out of the numerator? It is 1. So all we're left with here is 1 divided by x plus 7. So I hope this video helped, and I will see you guys next time.